This session is about problem analysis and programming style. So first we will see about different problem solving techniques. So any problem that you are going to take, you need to convert it to an algorithm and then refine that algorithm and finally produce a pseudocode. If you are going to write the pseudocode, then it will be easy for the programmers to implement the problem. Next, we will see the analysis approaches to analyze the algorithm. So there are two approaches to analyze the algorithm. One is space complexity, another one is time complexity. An algorithm analysis is a technique that is used to measure the efficiency of algorithm. Coming to space complexity is the amount of memory used by the algorithm to execute and produce the result. Space complexity is being classified as constant space complexity and linear space complexity. If the space requirement for analyzing the algorithm is going to be fixed, then it comes under the category of constant space complexity. Here we can see an example. So in this example, we can see that we are using four variables, variable A, B and C. So for each of the variables, we are going to have the size of that variable type. Here we have declared those variables of type integer. So depending upon the compiler, the integer is going to have 4 bytes. So 4 variables into 4 bytes plus the return value of z is also an integer value which is going to hold the 4 bytes. So summing up all this computation, we get 20 bytes to be occupied for performing this algorithm part. Next, coming to linear space complexity. In constant space complexity, we know what are the variables that has been declared and how that is being used. In the case of looping, we will not be finalized with number of iteration that will be executed by this algorithm, and henceforth the name is linear space complexity. Next, coming to time complexity, the second category. So time complexity of an algorithm calculates the time that is taken by the algorithm. If the complexity of algorithm is going to be high, then the time required for performing the operation using that algorithm will be complex. So we need to consider the time complexity also while writing our algorithm. The next step is for rules for writing the program. In the previous session, we have seen the structure of the program. In accordance with that structure, we need to frame the rules for writing the program. So first is a comment section. So for comment section is mainly used for documenting purpose. So we can document this section by either using single line comment or multi-line comment. Single line comment we will say by having a double slash. Multi-line comments will be a set of comment lines which is enclosed between slash star, and we have those comment line and then it will end with a star slash. Next rule is to use a termination by a semicolon. Every statement that we use in our program should end with a semicolon. All our printf statement, scanf statement and any variable that we are going to declare in our program should end with a semicolon. All the expression part is nothing but the logical computation that we are going to do. For example, if you are going to perform sum of two numbers, then we need to get the input from the user using the printf and scanf statement. Those statements should end with the semicolon. Similarly, the declaration part of the variable, that is int a, b, c, should also end with the semicolon. The expression is nothing but the computational part, that c is equal to a plus b, should also end with a semicolon. Next, coming to token identifier related rules. So any keyword that we are going to use in our program should not be declared as a variable. Those things we need to keep in mind while you are going to declare the variables, because keywords are some reserved words. Then it is the variable whichever we are going to declare is a case sensitive. So when you are going to declare int SUM, which is of uppercase, it will not be equivalent to the variable of smaller case letter of SUM. Okay, so then we need to take care of header file inclusion, because if you are going to use any predefined functions like square root, sqrt or pow functions, then we are supposed to include math.h header file. Similarly, when you are going to use string functions like string copy, string concatenation, string compare, then we are supposed to include string.h header files. Next, coming to rules about identifier or variable declaration. When you're going to declare a variable, it should always start with an alphabet or underscore, then preceded by any number is fine. Then there should not be any space between the words which we are going to declare. If at all is being required to differentiate the words, we can give an underscore. Int space, the variable name can be given as a identifier rule. Then coming to the next rule of opening and closing braces. So every open braces should encounter a relevant closing braces. Next, coding intention. So this coding indentation is required because for easy reading and editing of our program. Though it is not been used by the compiler for execution of program, proper indentation should be used in the programming practice. Next session is about documentation and testing. So whatever we are going to program, we need a proper documentation. So documentation is a written text which includes all procedures that are been incorporated for solving a program. So documentation session includes comments, description of the problem, solution to the problem, analysis and evaluation, designing, implementation and testing techniques and maintenance. So we will see a sample document for adding of two numbers. So first session was about comment. So in comment we can give the details regarding who has created the problem, what the problem is about, on which date it has been created. All the details can be given in the comment session. Next session was description of the problem. It states us or gives the brief explanation of what the program is all about. Next is the solution part. Here we will give the solution, like what is the user input that we need to receive and how we can perform the logical operation. What are the various means by which we can perform the operation. Here in this example we can see we can directly receive the two numbers and perform by adding the two numbers. Next solution is to repeat the incrementing of a by 2 times. The other method is to use predefined functions for adding. We can choose any one of the functions for performing your programming to get your desired result. Next, analysis and evaluation. So we have got three types by which a solution can be produced. So now we need to evaluate each type and find which type is best suited for our output. So we can say the first solution is best suited because this is easy and simple to understand. Next document is about designing. So designing states you what all the inputs that you have to get and what is the output that we need to produce. Then implementation is nothing but a coding part, how we are going to incorporate the logic of programming for the best suited solution. Next, testing technique. We need to test this program with sample test cases and find it works for all the condition. So in this testing technique, we have implemented the program by using or getting the user input of type integer alone. So if the test case is for getting the floating point number, then this program will not execute. We will be getting an error, and then we can try to implement this part also in the programming for performing the addition of floating point number also. So maintaining is to improve the efficiency by incorporating this floating point test case also into our program. With this, we are coming to the end of the session of Introduction to Program Solving. Thank you.